Welcome to Study Loop.
So in first part of this problem, we have to find out the solubility of AuOH3 in pure water. So in pure water, AuOH3 will be dissociated as Au3 plus 3OH minus. So that means, as we know that for a compound with a formula AmXn, we have the relation of its Ksp and molar solubility like this. Ksp will be ms to the power m, where s is the molar solubility, and then ns to the power n. So the Ksp value will be ultimately, if we rearrange it, m to the power m, n to the power n, and s to the power m plus n. So here our m value is 1, n value is 3. This is our a and this is our x. So if we just put the m and n values here, we'll have the Ksp expression as 1 to the power 1, 3 to the power 1, that means 3 to the power 3, that means 3 cube, and s to the power 1 plus 3, that means 4. 3 cube is 4. This is the Ksp, and we are given the Ksp value for AuOH3, which is 5.5 times 10 to the power minus 46. So this Ksp value is equal to 3 cube s to the power 4. And if we just solve this equation for s, we will find the molar solubility as 2.1 times 10 to the power minus 12 molar. So this is the solubility of AuOH3 in pure water. Now we have to find the solubility of AuOH3 in 1 molar nitric acid solution. So in 1 molar nitric acid solution, AuOH3, or the dissolution of AuOH3 will occur in 2 steps. In first step, AuOH3 will be dissociated to give Au3 plus 3OH minus, and then this OH minus will react with the H plus ion from the nitric acid, or HNO3. So H plus ion from the nitric acid will react with this OH minus, that means 3OH minus. Since it's reacting with 3, we'll have to put 3 hydrogen here, and finally we will get 3 molecules of water. Now if we just sum up this reaction, we can cut this 3OH and 3, and we will have ultimately AuOH3 plus 3H plus will be equal to, or in equilibrium with, Au3 plus from here plus 3H2O. So now what will be the equilibrium constant expression for this net equation? That will be the Ksp value. So the Ksp value we have is basically for this reaction. So the constant for this reaction is Ksp, which is we are given as 5.5 times 10 to the minus 46. And the constant for this reaction is basically the reverse of the solubility product of H2O. So the solubility product of H2O is Kw. So for the reverse reaction, it will be 1 by Kw. And since we are reacting here each of three moles or 3 molecules, that means we'll have to put a cube over this. So the result of this will be, this is the value of Kw. So this is the constant expression for this reaction. And as we know that the equilibrium constant for this reaction, which if we just consider it as K, so the value of K will simply be the product of KSP and the product of this. So the K of the net reaction, or the equilibrium constant for the net reaction, is KSP times 1 over Kw times our whole cube. And if we just do the calculations, 5.56 times 10 to the power minus 46 times 1 over 1 times 10 to the power minus 14 whole bracket cube. So the result from here will be 5.5 times 10 to the power minus 4. So this is the equilibrium constant for the for the for the dissolution of AuOH3 in nitric acid. Now we have to use this constant to set up the equilibrium constant expression to find the solubility of AuOH3 in nitric acid. So if we just write down this net equation one more time, and we have to set an ice table for this, so we'll write it here again. So the net equation is AuOH3 in solid will react with 3H plus in aqueous to give Au3 plus in aqueous plus 3H2O in liquid. So as we know that we ignore solids and liquids in equilibrium constant expression, we will just find the initial final concentration of H plus and Au3 plus, and this we will use in the equilibrium constant expression. So our initial concentration of H plus ion is basically the concentration of HNO3, which is 1 molar, and initial concentration of Au3 plus is 0. Basically, initially we don't have any Au3 plus deionized or dissociated or dissoluted or the dissolved in HNO3. And if we consider the change as or if we consider the solubility of Au3 plus in HNO3 as S, then the change in the concentration will be plus S. And since we have 3 hydrogen here, the change in the H plus and concentration will be minus 3S. And that means in final, we will have 1 minus 3S as the H plus ion concentration and S as the Au3 plus concentration. And eventually the equilibrium constant expression for this reaction will be the product over reactant, which is product concentration over the reactant concentration, and we have here S over 1 minus 3s. And okay, so we'll have a cube here because we have 3h ion. That means um, this will be basically 1 minus 3s whole cube. Now if we consider the solubility of AuH3 very small compared to the concentration of the acid, then we can ignore this s. And if we solve the equation for this s, we have, as we have the k value as we already calculated, is as 5.5 times 10 to the power minus 4 is equal to s over 1 cube. That means ultimately s is this. That means s is equal to 5.5 times 10 to the power minus 4. So this is the solubility of AuOH3 in 1 molar nitric acid.